Hey YouTube, what's up? Dr. T here, and welcome to the Altcoin Express and my hometown of St. Petersburg, Florida. So in this section we will be covering the Python coding of SensorWorld using tkinter graphics. So this is version 2 of SensorWorld Network Deep Neural Net, in which we will be saving the weights. The algorithm has been set up to detect when the error function has improved, and using a variable best_j to detect when it improves, and when that's detected we will save the weights and put them off-site into the file over there. And then when it comes round to the loop and starts all over again, it will have those weights already set in. So we start off by just giving ourselves a random set of weights to start off with, because we do need something. We can't just start with nothing. So we run a couple of cycles of random weights. So I'll set this down to like 4, because I've got silly number 2 in here, but that's alright. And run off a couple of cycles, and it's throwing an error. It's throwing an error because we don't have a best set yet, so we have to just give it an, get that right, give it an arbitrary value for the first cycle to get some weights in there and set up some kind of a number. So I'll just do that, and then we'll just switch that off. Where have you gone? We then switch that off, having done its job, and we now have a set of weights saved, and we'll switch off the random set of weights, since we will now be generating the new set of weights in situ from the game itself and saving them as an update as it goes through its cycles. Now we'll set this up to run a few loops, and hopefully it'll run okay, and we'll start picking up the bests as they come through the loop. Now that's starting to kind of pick up the next best and save it, and then bring the weights round to the beginning of the loop, so they've got a new set of weights every cycle, and that will then just progress on down the road until you reach a bump in the road, in which case you can then start varying whatever function you want. I mean, I've been varying the bias up or down a bit, and generally speaking it will go down, and it will take a few hours, but eventually it will maximize out to close to the 100%, as I've got 8 out of, there's 19 numbers in here, and I've gotten down to like 17 of those on 100%. So it's just a matter of going through this again and getting those bumped out. On 1 or 2 cycles I found I got locked into a local minima, in which case I just have to reboot it all over again. And remember that when you do something like that to save your weights, so now I've ported my last set of weights off into a folder, and yeah, this will just merrily go along, and it just takes time, and you can just run it out for whatever number of cycles you want. Unfortunately it's going to take a while. Let's kind of just put this on hold while it finishes. So we got 60% of it done, and it's still going down. We're getting a pretty reasonable number on the first run through, and the code will be put up on the post from my GitHub when I upload this, which I'll do shortly. So it's coming up to the end of its cycle, and it's still running pretty good. We haven't had any issues so far, and it will throw up the data. There we go, and there's that first run through. It'll put out the tracing that came out of this, and we'll move this up a little bit, and we can see what our data is. So we reached 99.78% accuracy on the first run through, and then you'll just flip it again and keep going until you hit a problem. If you do hit a problem, then what I've been doing, as I said, is just varying the bias and backwards and forwards, and then just tracing it out. To get to a very good training, it's probably going to take quite a few hours. I haven't gotten out there to 100% yet, so yeah, it could take 10-20 hours, but it'll get there, and job done.